Good morning, everyone. Thank you for joining us. It's Graph Guru episode 12, and we're going to introduce TigerGraph release 2.3. And we're going to do an overview of what's new in TigerGraph 2.3 and also do some demo around the new features. A couple of housekeeping items before we start the presentation. Everyone are muted in this presentation. And if you have Zoom issues, please contact the panelists via the chat. We'll also, at the end, we'll have the Q&A session for 10 minutes. And throughout the presentation, you can also send your questions at any time using the Q&A tab in the Zoom menu. And this webinar will be recorded, and you will receive an email with the recording. All right, so the exciting news is version 2.3 is available now. And there's the developer edition that you can download. And we also offer the Docker versions and VirtualBox versions. So you can download the developer edition through tigergraph.com/developer. All right, now without further ado, I'm going to pass it to Victor.
Thank you, Emma. So I'm here today with Emma. We are two of the product managers at TigerGraph. So we're going to do some tag team. I'm going to talk about some of the features, the new improvements with GraphStudio and GSQL, and she's going to talk about a brand new feature, the Kafka Loader, as we said here. So here's 4 major things are included in TigerGraph 2.3. The most significant is the addition of a Kafka Loader, which lets you integrate the TigerGraph platform natively with data streams. We're continually improving GraphStudio and GSQL. So we have some improvements to the query workflow and the way that information is displayed in GraphStudio. For GSQL, we are making improvements to both flexibility of the schema with primary key options and more options for how you load data, and some convenience features for examining what is already in your schema, what's in your catalog of queries and loading jobs. And as always, we're adding new things to our graph algorithm library. So we're going to tell you about 3 or 4 new additions there. So I'm going to start off with GraphStudio. As I said, I'm going to start off with these features and then let Emma do a more detailed discussion and demonstration of the Kafka Loader. So one thing we've done to start off with is we've made the query development workflow friendlier in GraphStudio. The whole idea of GraphStudio is to make it less technical, more natural, and more intuitive for users. And with that in mind, when we see opportunities to make it even better, we try to adopt those. So the first has to do with the authoring stage when you're designing your graph schema, or excuse me, when you are writing queries. Since you're referring to elements in the schema, it would be nice if you could see the schema at the same time that you're writing your query. So we've made use of the display to show you both. I'll demonstrate that to you in a moment. Oops, sorry. Accidentally moving my cursor. And then secondly, once you have written your query and you've installed it, then you might be just running the query in GraphStudio, but you might also want to take that query, which automatically generates a REST endpoint, which is then great for deploying in applications. So you can author your query in GraphStudio, test it out in GraphStudio, and then anytime you install a query, it has a REST endpoint. We can now have a very convenient feature for you to copy and paste that REST endpoint. And secondly, there are some improvements to how we display information. So I'll show those to you at the same time. So I'm going to take just a moment to switch to the GraphStudio window. So I've preloaded a schema and some data here. I'm waiting for this to start. There it goes. I had it on pause. There we go. So this is a medical drug schema. You can see it refers to pharma companies and reported cases, drugs. We're not going to talk about the use case here. This is just to show you examples of what you can do in GraphStudio. So if I switch to the Write Queries window, as you said, you see the schema here. So when you're writing queries, it's really easy to refer to the names of the vertices, names of the edges, and their attributes. So you don't have to keep switching back and forth to see that information. As I said, I have some queries already written. They're already installed. And I talked about the REST endpoint. So there's a new icon up in the menu here, this little globe symbol. So when you click on that, there's your query REST endpoint, and you can copy and paste that code if you're developing an app. You can just paste that code in. Another thing that we've done is with this output display, let me actually just run this query for a second so I can get some output. Advisor is the name. 10 primary. And so there's my graph output. Under the settings, you can now change the size of the text that's being displayed. So if that's too small for you, you can increase the text size. So particularly if we're zoomed out, if you had many, many items here and it was a little hard for you to read that text, you can adjust the size there under the settings here. Make it smaller or make it bigger, both for the label itself and any attributes that it's showing. So those are the improvements we've made in GraphStudio. And let me go back to presentation mode. And in GraphStudio, in GSQL, we've made two significant ones and a couple other ones. Actually, these three of them are functionality related. This one is a convenience feature for the catalog display. So I'll talk first about the primary key. So up here at the top, this is the classic traditional way that you would define a vertex type in GSQL. It's very straightforward, intuitive syntax. Create vertex. The name of the vertex type is movie, and we define the primary ID. So that's a keyword. I've capitalized all the keywords. So it's primary underscore ID, a name, a type, and then any other attributes you want. And I actually should say attributes rather than other attributes, because the traditional way in GSQL that you think about this first thing is this is really just used as an identifier, and for indexing, you actually cannot refer to it within the query. Like you can't search on this value, and that seems odd. Well, why would we do that? Well, we did that to save memory storage. As you know, we have very compact storage of the graph. We can be 5 or 10 times more compact than the competition. And part of that involves making choices like this. If you are doing full graph analyses where you're just analyzing every vertex, then you as a user don't need to name particular indices. We'll certainly tell you the names if you write a query to find, the most running page rank, you want to know which one has the highest rank. Well, we'll tell you what's the ID of that. But if you wanted to select a particular ID, that's not built in to this definition. Well, of course, sometimes you do want to do that. That's very natural. You do want to pick entities by ID. There's a way to do that. The way you do that is by actually duplicating the information. So this ID value here at the bottom, it's actually the same value here. So when you're loading the information, you would actually load it into two places. You would load it into the primary ID, and you load it into this second attribute. It seems redundant, but remember, this one's actually not being stored with the vertex. It's not taking up space. So this one was very compact, has limited usability, but this one, if you want the full usability, you just duplicate it. What we've done in 2.3 is we've actually made it a little easier for you to do that. If you want that to be duplicated, we'll kind of do it the more traditional way of just saying, okay, treat this ID as though it were an attribute. You don't have to manually duplicate it. Just use this this conditional clause at the end when you're defining the vertex type. Just say using primary ID as attribute equals true. Then, for example, queries like this, select M from movie where m.id equals 101, then you can do that because you defined this property in the specification, in the schema definition. There's another way to do that, which makes it look like, well, how would I have done this in SQL? In SQL, you would have written it like this, using the keywords primary key after the ID name, after the attribute name and type. So here it's just like a regular attribute, and I've elected this attribute to be the primary key. I do want to point out that this format is not yet supported in GraphStudio. So you can do all of this in GSQL. If you want to work sort of blending your workload, sometimes doing some things in GSQL, sometimes doing things in GraphStudio, we'd recommend for now that you use this first option. Okay, I'm going to go into depth in one more feature, and this is a new option for loading. So again, the classic functionality for loading in GSQL is we actually enable you to load edges before you load their corresponding source and target vertices. That's a flexibility that you don't get with most systems. The reason why we did that is for performance and also for parallelism. When you're doing things in parallel, you can maximize the speed and performance if you can loosen the restrictions on sequentiality. So this is a sequential requirement. If you say that the source and target vertices have to be loaded first before the edge, then you've put a constraint on things, makes it harder to do work in parallel. So we like to see do as much as possible in parallel. So if this were your loading job definition, I think I had let me fix a typo. I forgot to make this. This should say values here, I believe. Okay, so this is how you load data to an edge. It's got 3 attributes. Also, I'm sorry, this should also say, oops, sorry, this addition is not necessary. So if the data line begins with the character E, it's an edge. And here are its 3 attributes. If the line begins with a V, it's a vertex, and it's got these 4 attributes. So here's my first data line. It begins with an E, so it's an edge. And 1 is the source vertex ID. 2 is the target vertex ID. And mother of is just some other value, some other attribute. So that's only 1 line of data. It looks like we just create 1 edge. But if vertex 1 and vertex 2 don't already exist, it will automatically create them. So this 1 line is actually going to create 3 things. It's going to create a person vertex with ID 1 and just default values. They happen to be strings. So default empty strings for the other attributes. It'll create person 2. and then it will create this edge called related. Type is related, 1, 2, and mother of. Okay, now what we've done is we've added this new option called using vertex must exist equals true. Because what we did there with automatically creating the vertices, that's not always what users want. Sometimes they would have considered that actually bad data, that if their data is not guaranteed to be clean, then it might be actually be a faulty reference to a non-existent vertex. And then they don't want that edge loaded. So by specifying this option that will say, if you don't see that the source vertex and target vertex already exist, then reject that data line, do not create that edge. So in this case, this is what you would get. You would, when it would get this data line, it would actually reject it and not create that edge. And there were a couple other improvements in GraphStudio. I could very quickly show you. Well, I'll show you one of the convenience features. And one of the convenience features was to I said show more of the catalog in a more tailored way. So if I enter the GraphStudio interactive mode, excuse me, GSQL, sorry. So I'm entering GSQL, should work. Is my machine running? I had my machine on pause, so might not be running. Was not that big a deal, so I think I'll just skip that. Sorry. It was just so rather than listing out your entire catalog, you could be selective and show only certain vertices, only certain jobs, etc. So let me talk about the GraphStudio. Excuse me, I keep misspeaking. The Graph Algorithm Library, new additions. And then I will turn it over to Emma to talk about the Kafka Loader. So several new additions to the Graph Algorithm Library. You can see all about it by going to our documentation center, so docs.tigergraph.com. You see the main menu there, and it's very easy to find the Graph Algorithm Library. That's got the documentation as well as a link to the GitHub source code. So first of all, we've added a new category of similarity algorithms, and this is a very important category. Obviously, for things like recommendation, you want to recommend similar products. You want to find out which persons are similar, and then recommend products that similar people liked similar products. If you're trying to do entity resolution, that's when you have two different entities, say persons, where you suspect they might represent the same physical person, and you have to decide whether to merge them into and make them actually the same entity. And you do that by looking at the clues. What do you know about them? Do they have similar characteristics? So there are many different ways to measure similarity. There's not just one formula. So we've got two general types. One is based on sets of properties. Which properties do you have? And cosine is looking more at numeric values. If you all have the same properties, then what are their values? And often you use a blend of these. You can build a more sophisticated similarity algorithm by combining set-based Jacquard with value-based cosine. We've expanded the centrality category with personalized PageRank. Everybody has heard of PageRank, where you look at an entire graph and pick out the most influential entities, rank every entity according to their relative influence. And those are global properties. But sometimes what you want is a more personalized perspective, not who is influential globally, but which entities are important to me? So in this case, you define one or more home vertices or source vertices, and that's like you're doing a web search starting from a home page and thinking about, if I'm walking the web, but this is my home, this is where I start, and every once in a while, I just jump back to the home. That's similar to what's the random walk with personalized PageRank. So that's very important for many applications. In the path category, we have more variations of shortest path. I can name 3 basic cases where the paths are unweighted. In that case, you're just counting number of hops. There's the case where they have positive weights. In that case, you're looking for shortest total distance if you're thinking of routes. If you think of them as prices, you're thinking of cheapest price. So there you add up the weights and along the path. And there's a slightly more complicated case where you could have negative weights, where you actually benefit by taking this edge because you're actually subtracting distance in a way by traversing that edge. So that requires an even more complex algorithm. So we provide 3 different variations of the algorithm because we want to give you the cheapest one, the most efficient algorithm for each case, whether you have unweighted, positive weights, or possibly negative weights. And lastly, we have a whole category of community detection algorithms. One of the most popular is the Louvain method for measuring modularity and using modularity as the way of defining partitions in the graph. We developed actually our own custom algorithm by looking at several research papers, taking the work of multiple papers and combining them to come up with one that's really good for parallel processing and really good for the TigerGraph engine. So there's a new, much faster version of Louvain modularity. I've pretty much finished my part of the presentation. I'm going to give an overview of the Kafka Loader, and then I'm going to turn it over to Emma. So Kafka, as most people know, it's an Apache tool. So it's free open source code, and it's really designed for streaming applications where it is a manager for data coming in and going out to multiple distributed systems. It has many benefits, such as increasing the data availability, and through this, it accelerates your time to value because we have built-in natural support for Kafka. A lot of people already have Kafka, or they know how to use it. So you're going to be able to deploy it faster, and you're going to be able to actually process your data faster. The syntax that we use to set it up and to operate it is very much like our existing GSQL syntax, so nothing new to learn. And then it has all the benefits that Kafka brings. Kafka is a mature, reliable, robust tool. It has many benefits, and Emma is going to go into more detail with those. So I'm going to stop sharing screen and let her take over. Emma?
Thank you, Victor. All right, let me present from. Let me introduce you about the new feature Kafka Loader in depth. All right, Victor already talked about how Kafka is a very popular pub/sub system now in the industry. It has gained tremendous popularity in many of our customers. And we're very excited that with 2.3, we provided the native integration with the Kafka platform so that we can get to this, the value of the data from the real-time streaming data. What we really want to bring to our customers is to bring this available new data and into your graph quickly. We don't really want you to have sleepy data in your data lake. You can put your data to use right away and getting the insights right away with TigerGraph. So the new integration with Kafka, we provide the GSQL query language support And with that, you can use a similar syntax with the original data file loading syntax in TigerGraph. And the Kafka Loader works for both streaming data and batch data. And it also can help you to do the one-time initial data import from other data stores. I want to mention that in the advanced machine learning integration cases, Kafka Loader here can enable you to get to the real-time graph feature updates very quickly. This will help you to tune your machine learning model much more easily with the updated graph and also the updated new graph features. Another important design choice we want you to remember is we designed with the built-in multi-graph support for the Kafka data loading. So just imagine if you have two business units. Okay, one step back. For people who don't know about the multi-graph feature with TigerGraph, we provide separation of control for different graphs within the same global graph. So with the data loading aspect for Kafka, we also designed the control. If you have two business units that want to load Kafka under their own business units, you can load that into their respective graph in this global graph. So there's no mixing of duties and responsibilities, and you won't be seeing data from the other business unit. The reason that we choose Kafka is an industry standard PubSub framework now. Many of the customers are using it. And now step back a little bit in case you're not too familiar with Kafka. Kafka has a few of the major components. If you look at this diagram, there's the Kafka producer, which allows you to publish a stream of records to one or more Kafka topics. And then on the other side, there's Kafka consumer, and it allows application to subscribe to one or more topics and also process the stream of records. And then there's the Kafka stream, which acts as a stream processor, and it can consume an input stream from one or more topics, and also produce output stream to those output topics. And lastly, there's also the connector ecosystem, which allows third-party or the Kafka platform to build and run reusable producers or consumers, which also connect the Kafka topics to some of the existing applications or the data systems. For example, if you have a connector to a relational database, it can capture the change to a table. But in our case, you can imagine that TigerGraph is on the right side for this Kafka sync connector. So we are providing our customized Kafka Loader here. And you don't really need to install standalone package for Kafka Loader. It's already part of the core TigerGraph engine. So it's not a normal sense sync connector in that case. So we chose Kafka because it's very extensible and flexible. If you have Kafka in your system, you can pretty much import from all of the different data sources, leveraging the existing Kafka connectors. Here's some of the benefits for the Kafka platform. And this is also why we are using Kafka and helping our customers to adapt to this framework to import data. It is a distributed PubSub system, so it's very scalable, and it also has built-in fault tolerance. And this aspect will serve as a data buffer for TigerGraph, because Kafka is in a separate cluster, so there won't be problems from data loading to crash the TigerGraph system. The Kafka framework will help us to be that buffer. There are quite a few benefits here from the Kafka ecosystem. The high throughput, the low latency, the real-time handling, high concurrency. I encourage you to read more about Kafka framework and how that could help you to import data to TigerGraph system. Here's a brief diagram outlining the Kafka and TigerGraph data pipeline. From the left-hand side, if you have the streaming data sources or static data sources, like other relational databases or NoSQL databases, you can put through the Kafka connectors. And then between Kafka and TigerGraph, we have this new feature, Kafka Loader, and it will load the data into TigerGraph. And from TigerGraph, you can work on your graph analytics and using the algorithm to do the real-time graph analytics and feeding into your applications and business intelligence application or your graph visualization tool. I want to go a little bit into more of the technical detail here. This is a high-level Kafka Loader architecture. I'm kind of focusing on the TigerGraph part on the right-hand side. If you look at this diagram, there is an external Kafka cluster you have to set up. That's serving as your data source. And it loads into the TigerGraph REST PP server. And for configuring and managing the data loading, user use GSQL query and going through the GSQL server and talking to the REST PP server. So there are two configuration files that you need to configure at the very beginning. The first one is the Kafka cluster configuration, and the second one is about the Kafka message, like the topic, partition, offset information. I'll talk about it in detail in the next few slides. A quick 3 steps for the initial Kafka loading job. It's very consistent with our GSQL data loading steps, which is already prior to 2.3, we already had that syntax there. So the step 1, you define the data source. Here is the Kafka data source. Step 2, you create a loading job. And step 3, you run the loading job. So it's very easy, 3-step process. And I mentioned earlier that there are a few prerequisites here. You need to provide 2 Kafka configuration files. In step 1, when you define the data source, you need to provide the Kafka cluster configuration file. This configuration file will have the Kafka broker's domain name and port, and it helps you to connect to external Kafka data source from TigerGraph. And in step 2, you need to provide the Kafka topic and partition config file. And this config file will include the topic and partition list and start offset. And this is how we are defining and TigerGraph recognize the Kafka data source structure. All right. There are few steps that you can manage the loading jobs. This is very consistent with the regular GSQL data loading syntax. You can show the loading status, you can abort the loading job, and you can resume the loading job. And here is a example for showing the status of a particular loading job. You can see that, okay, the information tells you the topic partition, what is the topic, and the loaded messages, how many messages is being loaded, and the average speed, and the duration, and loaded size. I want to mention that the duration here is actually includes the idling time. So it is for the streaming case. So if you're doing batch loading, it will also count the time in between the two batch job, unless you abort the loading job and resume later. One distinction here, abort loading job here means pausing that job. We're not discarding the job with this command. This is an example scripts that from the start to finish. You can see that you can create the data source, Kafka K1, for a graph, test graph. And you can set the data source here, K1, with the configuration file. This is telling where the Kafka cluster is. And you can define the loading jobs here and create a loading job for a particular graph. In the file name of F1, this is telling the topic partition configuration so that we recognize, TigerGraph recognize the messages that sent through the Kafka cluster. All right, let me go for a live demo of the Kafka Loader. So I already did some prep work for this live demo. I set up an external Kafka cluster. And I also set up the TigerGraph cluster. And the two configuration files are already stored on the TigerGraph server. And for this demo purpose, I had a very small graph, which constitutes a graph called ComputerNet. And the vertex is computers, and edges are connections. So the goal of the demo here is to show that the pipeline is set up, and the data is flowing from Kafka to TigerGraph. It's not really for the purpose of performance or benchmarking. And actually, in the next Graph Guru webinar, we're going to load about 450 gig of Bitcoin data into TigerGraph using Kafka Loader, and also explore the Bitcoin transactions and network. So if you want to see like with a larger data set, you can come to our next Bitcoin blockchain webinar. What I'm going to do is I will show you the initial loading steps, the define, the create, and the run the loading job. And then I will also manage this loading job, showing a few of the commands, show, abort, and then resume. All right, let me stop share the slides and sharing my console here. All right, so I hope everyone can see my console here. So this is actually connecting to a few of the remote clusters on the cloud. I have a single node Kafka cluster, both serve as a producer and a consumer. And this other one, all right, I think it stopped share. Let me stop share. And it seems that when I go to the other console for the Kafka Loader, the TigerGraph engine, it doesn't switch for window very smoothly. Okay, so I'm just going to stay in this console, this terminal, which shows the TigerGraph server. And I have a Kafka Loader test folder here. Let me show you the first JSON file. This is a JSON file that's telling where the Kafka cluster is. Then let me go to the next configuration file, which is as the loader vertex.config. This is the configuration file that tells what the Kafka message structure is it tells what the partition and start offset is for this particular Kafka loading job. Then I'm going to show you the Kafka loading job GSQL query. Okay, if you look at here, we're using the graph computer net and then creating the data source test 11 for graph computer net. And I specified the test1 JSON, that's where the Kafka cluster is. And in this create loading job, I also defined the file name, this particular file, which has the configuration for the Kafka message data structure. All right. So I already ran this particular loading job, and now I want to show you into the GSQL TigerGraph engine console and what is our status here. I'm using the graph computer net and showing the loading status for this particular. Oh, so I stopped this loading job before the webinar. So let me go back and resume it. Okay. So now you can see that the resume is success and the selected job has resumed. What I'm going to do now is from the other Kafka cluster, I'm going to run the data generator. Now there's one file that's sent. So let me show the loading job status now. All right. It shows that there's 2 loaded messages here. I'm just going to show load another message from the Kafka cluster. And you can see the loaded message is going to 3 right now. And you can see a lot of the other status here, the duration and the loaded size. Again, this duration here is the entire duration, including the idling time that was between the resuming of the loading job and when I hit sending the message through Kafka cluster. Let me just do one more push for the message from Kafka cluster. Okay, now you can see the loaded message 4. Let me stop this loading job using the abort command. So currently the TigerGraph engine is trying to abort the loading job. This is great. We can see at the end of the aborting, and you can see the summary of the entire loading job. There's a loaded message 4 and duration and also loaded size. It's consistent with the status we just saw earlier. Okay, so this is the end of my demo. So I'm going back to the slides. Hope you enjoyed the demo. Okay, let me just summarize what our webinar covered today. First, great news, version 2.3 is available now, and you can download the developer version and try all the operations that we just showed and demoed in this entire webinar. And there's a bunch of enhancements in GraphStudio and GSQL. You can check out the documentation about all the details. And our graph algorithm library is expanded. So try those new algorithms. And hopefully you will also try the Kafka Loader So it's very exciting that you can ingest your real-time data and get your data to graph in a very timely fashion. All right, now let's get to the Q&A session.
Thank you, Emma. So thanks to all of you who've been with us today. We are going to stay around for several minutes. If you have any questions at the bottom of from your Zoom control panel, you can type in your questions at the Q&A panel. We had a couple early on, but want to see if there are any more. We did receive a couple questions just through email. So let me read out one of them. This is a pretty general one. So Emma, you talked about how the Kafka Loader is integrated natively. It uses similar syntax to TigerGraph's regular loader. Does that mean you can use it through GraphStudio?
So the first phase was 2.3. We don't have it with GraphStudio yet, but it's definitely on our roadmap to have that integration through GraphStudio.
Okay. And also, so other than Kafka, what other ways can TigerGraph accept input data?
There are many ways that you can input data. So pretty much all data sources. For example, there are ecosystem connectors that you can leverage. You can input data from Hadoop, Spark, and RDBMS. Those are the open source connectors that you can leverage and modify to your use. And we're also developing S3 connector natively, which is coming very soon with the next release. And you can also just the most generic way to just load through your CSV file or your JSON file into TigerGraph. You can also post data into TigerGraph. So there are many ways. So pretty much we cover all the cases.
Okay. And let's see. Here is one from an anonymous attendee. Where do you include SSL, so configuration details, so secure connection configuration details for the Kafka consumer? Is that in the broker config file?
So it's already configured in underlying architecture. So it's not in the Kafka configuration file.
Okay, so you say it's actually part of the general
Right.
TigerGraph setup. It's not specific for the Kafka consumer.
Yeah.
Okay. There's one question that seems maybe is more to my part of the presentation. So it's about GraphStudio. So a user, someone who has used GraphStudio in the past, noticed that if you run a query and are looking at the result and then switch to a different panel and then come back, that the query result has disappeared. Are we going to make a change so that want to make sure we were aware of that and can we fix that? We are aware of that. So it is on our backlog feature request list to do that. But there's actually a current workaround. The current workaround is if you're viewing GraphStudio in a browser, you can just open another browser window or another browser tab to view your other panel of GraphStudio. You can be viewing one session of GraphStudio in as many different browser windows or tabs as you want. So each one could be showing a different GraphStudio view. So we're working on the feature change that this person requested, but there's a way you can just work around that problem right now. Okay, I see a couple more questions. Does TigerGraph provide RDF reasoning or an inference engine or integrate with the same? So I'll answer that. TigerGraph is a property graph. There are two major flavors of graph databases out there. There are RDF style semantic graphs, and there are property graphs. So there are like other full-featured property graphs. We can import RDF data, but once it's imported in, we follow the RDF model. We follow the property graph model. So now the question about inference. Do we have inference? We do, because you can write GSQL queries that effectively execute inference. The phrasing you would use, we're not using the Sparkle language, we're using the GSQL language, but you can do inference. Let's see, the last question, what's the release plan for saving display attributes for the vertex? So it's a bit annoying to, I guess, in GraphStudio to set the settings. So, you're showing configuring the display, and then again, it's not persistent. That also is on our feature backlog list. I don't have an exact schedule for that. It might make it into our next release. I'd say either our next one or the one after that. So we're currently on 2.3. So the next one would be 2.4. We've already announced some details about what would be in 2.4. The most exciting feature in 2.4 is going to be the pattern matching with compute. We've talked about that before. There's actually also going to be several significant things about in 2.4, which I don't want to, we're down to the exact days and weeks of when it's going to be released. We're trying to finalize everything there, so I'm not going to promise a particular date, but it's in the final stages. I don't see any more questions coming in. So maybe we'll wrap it up for today. So we've told you about what's available in 2.3. You can, of course, download 2.3 from our website. We have a developer portal, which has a lot of FAQs, a lot of training resources, a lot of solution use cases at tigergraph.com/developers. You can download the developer edition, or you can get an enterprise edition free trial and find out what's the difference between the two versions. At our download website, we have all the examples we have shown through our past Graph Guru sessions are available for you to download on GitHub, and similarly, the Graph Algorithm Library is also on GitHub. And we have a developer forum. So if you have comments, questions that you weren't able to get in today, you can send them through that discussion forum, and we'll be happy to do that, happy to answer them. So thank you for joining us today. Thank you from me, Victor, and Emma. Any last words for our viewers?
Yeah, thank you for coming to the webinar. Download our developer version, and definitely also try out our newly available AWS paid AMI. So if you want to go from AWS directly, Marketplace directly, you can also use that. So yeah, thank you, and have a good day.
Thank you, everyone. Bye.
Bye.